Thank you everyone for joining us today. Right, I'm Rob Reid. I'm Cockroach Lab's technical evangelist, and I'm joined by the very wonderful David Bressler. David, thank you very much for joining.
It's a pleasure, Rob. Always love doing things in collaboration with you.
How are you doing?
I'm doing great, doing great.
Good.
And so, just to Rob introduce himself, let me just take a second to introduce myself. I'm also obviously with Cockroach Labs, and I'm the staff product marketing manager, so responsible for helping our customers understand the value of what we're doing and how we're doing it.
Super. Thank you very much, David. So today we'll be talking about the unique selling points of all of the databases that we've mentioned in the preamble to the webinar. We'll be highlighting the key differences between the AWS databases and CockroachDB, and we'll be exploring the decisions and the considerations you might want to make when choosing any of those databases. If you have questions, the chat function should probably be disabled, but the Q&A function isn't. So if you've got questions, bung them into the Q&A and we'll get to them as quickly as we can. We are joined by our colleague Sai, who actually comes originally from AWS. So should be in a very good position to answer some of your more hairy questions, but do keep them coming in because we will answer them as soon as we can. We'll be sharing a survey after the webinar, and we'll be sharing the slides as well in anticipation of your questions. Before we get going, though, I'd like to say a big thanks to Morgan Winslow, who ran a very similar webinar at the start or towards the end of the year before, or about a year ago. So a big thanks to him because it was his slides that we used to create a lot of this work. And a quick disclaimer, like Morgan gave before he started his, neither David nor I'm speaking for myself, correct me if I'm wrong, David, are experts or deep experts in any of these AWS products. So we would definitely encourage you to try all of them before you take our word for granted. We have an amazing partnership with AWS, so we're not coming at this from a competitive angle. It's more just highlighting some interesting information. You may have also noticed that there's a poll. You're very welcome to participate in that, just to kind of gauge the interest in the various AWS databases available. Without further ado, let's get cracking. We'll start by looking at the AWS solutions. Now, AWS has been around for many years, and the databases that it runs have been around, battle-tested, production grade for many years as well. First, we have RDS, which is a relational database system in the cloud. So you've got your typical Postgres, MySQL, Oracle databases, I think maybe SQL Server as well, many different relational database flavors available. That runs on dedicated infrastructure, and it has a single writer topology. So it scales for writes vertically, essentially. Then we have Aurora, which is where compute and storage have been disaggregated. And there are more out-of-the-box features, but slightly fewer flavors available. You've got Postgres and MySQL available here, and it's also available either as dedicated infrastructure or serverless. So high amounts of scale up and scale down. Again, a single writer interface. Next, we have the global database, so Aurora Global Database. This is essentially Aurora, but deployed across multiple regions. Now, next we have serverless. There was a V1, we'll be talking about V2. V2 scales up and down in small increments with use, and it scales up and down very quickly, so you're never overpaying for what you're not using. Next is limitless, and that aims to address some of the limitations with the single writer interface with the previous databases, and it does so via sharding. So if sharding a database is something that you have an appetite for, limitless could be a good choice for you. DSQL aims to address some of the limitations in limitless, and that is it takes away the need for manual sharding that you have to do in limitless. It's an active database, and we'll be talking a bit more about DSQL in a minute. Contrast this with CockroachDB. We have three main products. There's actually two main products. One is managed by CockroachDB in Cockroach Cloud, and there are three flavors available. So one is serverless, of which there are two products. There's basic and standard. Basic is more akin to DSQL in that it scales up and down with your usage. And then there's standard if you need provisioned throughput, so guaranteed level of provisioning, which AWS also has support for. Next, we have dedicated hardware. So you would have a number of servers, and we call that our advanced tier. Both at this, there's also a self-managed. Ultimately, CockroachDB is deployed as a single binary Docker image or Kubernetes pod. So you can self-manage it in Kubernetes, EC2. It's available on the AWS marketplace, and you can run it on Outposts. So you can run it wherever you need to run it. You can also run it across cloud or hybrid if you want to run across cloud and on-premise. You can also keep it completely on-premise or run it in the mainframe if you need to. David.
Yeah, Rob, since you mentioned Outposts, and since we're going to be talking about DSQL, that's one of the things to keep in mind. If you've got a place where you need to keep data local, and in particular, I'm thinking about the gaming industry, especially here in the US. Every state has its own regulations. DSQL is just not a solution for that because DSQL has limited regional support. We've got customers who are running on Amazon Outposts in almost every state of the union, and they're keeping according to the regulations, as they're supposed to, they're keeping all the bet data local, and they're reconciling those bets locally. And Rob will explain how we do that, but I just wanted to point that out since Outpost came up.
Yeah, thank you. And finally, we introduced Bring Your Own Cloud more recently. That is a completely managed offering, but it runs on your own infrastructure. So let's take a look at a feature comparison of each of the databases. We've got CockroachDB in the left column, then Aurora, Aurora Limitless, and finally DSQL. So the ability to scale elastically, i.e. up and down, without the need for sharding is one of CockroachDB's strong suits, and it's one of DSQL's strong suits. The sharding complexity is taken away from the end user. You simply hit an endpoint, you store data, you retrieve data, you don't have to worry about the sharding. Now, Aurora only scales horizontally for reads, so you would add read replicas in order to achieve scale. We'll talk about that in a bit more detail. Limitless scales for writes via sharding. Next, we have always on with zero data loss. So this is the resilience aspect of things. Aurora uses failover from read replicas. You can promote read replicas in the event of a writer failure, but that does necessitate downtime and may incur data loss depending on your backup schedule. Limitless has the same kind of profile as Aurora. DSQL has single region survivability because, as we'll see in a minute, you can run across two regions with a witness region, and that allows you to survive an AZ outage. Next is all about storing data close to customers. This speaks to what David just mentioned. If you have users who are dispersed around a country or a continent or the world, and you want to keep data close to them for low latency reads and writes, or maybe for the purposes of satisfying regulatory compliance, which can be a maze of very complicated regulations, that's this point. CockroachDB has built-in geo-partitioning, so you can pin tables or individual rows wherever they need to be within your cluster. So in different rows for different countries for different users. This isn't possible for the AWS products, so they have an empty pie here. Next is deploy anywhere on any cloud. I won't labor the point here because these are all AWS databases and as such run in AWS. Finally, familiar compliant SQL. Now, CockroachDB has strong Postgres compatibility. Aurora, on the other hand, is just Postgres. So it has full Postgres compatibility, where CockroachDB might be missing a few of the more exotic features of Postgres. Finally, we have Aurora Limitless, which has some limitations and doesn't support strong isolation. And then DSQL, which is further back in its journey. It's a bit more of a new product in AWS's arsenal, has slightly lower Postgres support again. But it will catch up as time goes on. So let's explore some of those limitations. In DSQL at the moment, and again, I'll preface this with this might not be a problem for your workloads. This might be absolutely acceptable. But you can have one database in DSQL. You're not able to create any more, and that database is called Postgres. Again, this might be completely fine for your workloads. You're able to create up to 10 schemas currently. And in transactions, you're able to run inserts, updates, and deletes on up to 3,000 rows at a time. Again, if you're wanting to run huge batches of things and lock up tables, you're not going to be able to do that here. But I'd question whether you'd want to do that anyway. From a deployment perspective, it's not available in every region. Last time I checked, it was around 10 of the regions that I can see of all of the available regions in AWS. And it's a managed service from AWS, which is serverless. So there's not provisioned tenant specific provisioned hardware. And it's inherently multi-tenant, which will work for some companies, but not work for others. Same as our basic and standard offering in the cloud. Peered regions. So if you have two regions in a DSQL cluster, they must share a witness region. The regions aren't therefore homogeneous because one of those regions is slightly different, being a witness region that you wouldn't directly talk to. You can't add regions to a single region cluster. So if you create a single region DSQL database, you're not able then to create multi-regions from there. You'd need to essentially start from scratch. And finally, something that I, as a developer, have noticed is it uses token-based authentication. So you would generate a token for a particular lifetime. You'd use that as the password in your connection string, and you'd need to then refresh the token. I think there is a maximum token duration that you can have, at which point new connections would start to fail. I'll just talk about the SQL compatibility a little bit, but again, I won't labor it. So from a SQL compatibility standpoint, again, it's a new product, so its compatibility is a bit lacking at the moment. It doesn't support foreign keys or foreign key constraints at the moment. Now you can simulate this with, just column to column. You can still perform joins, but there isn't the foreign key constraints. There aren't any views or temporary tables available yet, nor are there PLPG SQL functions, although you can create SQL functions, which might be enough for your workloads. And there's no triggers or sequences available yet. There's no way to partition data. There's no vector support, and geospatial data doesn't exist just yet. From a safety perspective, it's currently just full backups of your cluster, no incremental backups, which might be a consideration for you if you tend to run incremental backups intraday. And if you want to restore, you'll have to restore the entire cluster in one go, as opposed to restoring things at an item level. I've used the fault injection service from AWS to perform resilience testing against DSQL, and the only test you're currently able to run is a region outage test. So essentially it takes out one of your regions, at which point the connections start to fail for that region, but the other regions are unaffected. So it can survive at most one region, being a witness region setup. And obviously, being an AWS product, if you only run in AWS, this will be fine for you. But if at some point you want to try other clouds, you are locked into AWS at that point. It also only provides snapshot isolation, which if you're not treating it as a serializable database, will be fine for your workloads. But if you are, you may run into some issues. One is the global invariance violation, which looks like this. This is the canonical example of invariance violation. So if we have two doctors on call, Alice and Bob, and their value for on call is set to true. If one of those doctors wants to take a day off, so they go on call set to false, they start a transaction, they check that there are doctors on hand, they set their value to false, whilst concurrently another doctor is doing exactly the same, that both transactions will commit. So we'll end up in a situation whereby there are no doctors on call. That's the invariance violation. We do have a quick question here. I've just seen this. So as there are so many limitations for DSQL, then what is the use case for DSQL? It's a good question. I'll answer that now. If you are actually, you know what? You've preempted some further slides. So what I think we'll do, unless you want to get onto it now, David, is to continue on and we'll address your question.
Let's wait for the slides, because we've got slides that talk exactly to where DSQL plays. And the short of it is, if you're an Amazon shop, DSQL is a very strong story. If you're already familiar with their tools and all of that, it might make sense. And in particular, it's not just about the technology and the skill set, but often also about the process. I worked at a company, I worked at a big bank once, and all I had to do to create an Oracle database was open a trouble ticket. And so opening a database was there was a process for it, there was accounting for it, there was governance around it. It was very simple to do. And so if you are an Amazon customer, you've probably got those internal processes and procedures in place, and nobody's going to look at you sideways if you say, hey, I want to run this different Amazon product. So I guess maybe we'll cover it now
Yeah.
because that's
Yeah.
pretty much what the
Yeah.
slide says.
Yep. I think that's put beautifully. If you're a heavily into Amazon and you're developing your business on top of Amazon, DSQL will present a lower barrier to entry, provided you can get around those limitations. So if you're starting a new project and you're not migrating a large complex workload, DSQL might be a perfectly fine fit for that. Moving on, we'll look at the value propositions of some of the AWS databases and then dive a little bit deeper into Cockroach. So from a DSQL perspective, this is exactly what we spoke about a second ago. For companies who are deeply invested in AWS in terms of not only the ecosystem, but also the skills, DSQL presents a lower barrier to entry because you probably already are familiar with how to access AWS products, the token authentication process. So it's a lower barrier to entry. And it yields infrastructural benefits being built into AWS, one of which being the journal. That's a component which I'll talk about in more detail in a minute, but it's used elsewhere in AWS. So it's been, while DSQL is brand new, some of the projects that underpin or services that underpin AWS already use the journal. On to CockroachDB. CockroachDB, as its name suggests, is one of, if not the world's most resilient database. It offers zero RPO, which is recovery point objective. That's zero data loss in the event of an outage with minimal RTO. We're talking an average of about 4.5 seconds worth of downtime. It can survive machine, data center, AZ, region, and cloud outages, depending on where you deploy your clusters. And it scales for both reads and writes. As we'll see in a minute, every node in CockroachDB is the same. There's no special writer node or primary node. There's no read replicas. All nodes participate equally in the workload, and they figure everything out for you. So you get global consistency no matter how big your cluster grows. You can also reduce total cost of ownership. It has Postgres compatibility, which should lower the barrier to entry if you're already a Postgres shop. And there are flexible deployment options, as we looked at a minute ago. So you can either self-host it yourself, or you can use our managed service, or a combination of the two via Bring Your Own Cloud. There's also built-in change data capture, or CDC. So if you want to pump data out of CockroachDB in a transactionally consistent way, you can do that with CDC. So send messages to Kafka, WebSockets, etc. And finally, you can run it anywhere. It runs across all the major hyperscalers. It's available in all of the marketplaces for all those hyperscalers, and you can run it wherever you need to. Now, let's take a look at some of the architectural differences. Again, if there are any questions along the way, anything that you wanted to ask earlier but didn't, you can bung your messages in the Q&A and we'll get to them. First, we'll start with Aurora. So I know Morgan, when he ran this a little while back, he referred to it as standard Aurora, and I think that probably makes more sense. So standard Aurora offers enhancements over RDS in that it separates compute and storage and offers some quality of life improvements over RDS. And you scale horizontally for reads. So you add read instances, you scale read instances horizontally or vertically, depending on your requirements. And you can also deploy read replicas in different regions, AZs, and potentially globally if you need the distribution of reads, and you can tolerate the latency of the asynchronous replication from the primary region. There's also only one writer node. So in Aurora, if you want to scale for writes, you have to scale vertically. That means a maintenance window, that means downtime. And that's typically what people talk to us about when they're talking about Aurora is the single node writer architecture. They tend to hit a scaling limit for writes, which is very high, but their workload has outgrown Aurora and they need something that scales. And I think that's why we start to see what we'll talk about in a minute, Aurora Limitless and DSQL coming into play. Next, there's the storage layer, which is a collection of machines with SSDs spread across multiple AZs where data is written to multiple times for durability. And finally, resilience. So you've got good resilience for reads, being a horizontally scalable for read service with read replicas in different AZs, although there's a single point of failure for writes. If you lose your writer instance, you'll need to promote a read replica in order to recover within a couple of minutes. So in short, it's a great solution, but you might outgrow it. And that's where other tools come into play. We've got Aurora Global, which is regular Aurora database essentially, but it's converted into a global database by adding additional regions. Provided you don't use the built-in secrets manager from AWS, you can't create a global Aurora database if you're using the built-in secrets manager. You'll have to manage your own secrets. Next, we take a step up in terms of scale and we go to limitless. So this exists somewhere between Aurora and DSQL. There's a cluster endpoint, which is the single entry point into the cluster. So there's no separation of writer instance and read replica instances. And that's exposed for both reads and writes. There's a router, which routes client requests to the database shards. And the routers are responsible for consistency in the database. The shards store a subset of data depending on the table type that they are storing. So a standard table will exist on one shard, and that's determined by the system itself, not by the user. There are sharded tables whereby a portion of your data will exist on one of the shards, but not more of them. And finally, there's global tables, or a reference table, where data is stored across all of the shards for lower read latency to those shards at the cost of higher write latency. Although Limitless can't serve global reads in the same way that Aurora can. So there's a trade-off there. Next, we'll come on to DSQL. So we'll start from a very, very high level. And actually, the last time we spoke about this, where Morgan did his presentation, Aurora DSQL was actually in preview. Since then, it's gone into GA and it's available in more regions. So at a high level, DSQL supports reads and writes across multiple regions. It achieves multi-region resilience via a witness region. So you'll have up to two regions with a witness region. They have to be in a region triplicate or something like that. I think that is the terminology, in that you are able to create multiple regions, but they'll have to exist within the same continent. You couldn't, let's say, create a region in the States and a region in APAC with a witness region in Europe, for example. The two regions would have to share the witness region, and they'd all have to be co-located within a specific geography. We've got another question here. Does Aurora Limitless rely on single catalogs similar to Oracle Global Database? I honestly don't know. I don't have the answer to that. So unless you know, David, perhaps that's something that someone from our team can quickly look up for you.
You can follow up on.
Yeah, exactly. We have another question. How is
GIS support?
Yeah, for CockroachDB. How is geometry stored, and is there support for rasters and LiDAR point clouds? So in terms of rasters and LiDAR point clouds, I'm not sure. We store, so we support PostGIS in CockroachDB. We support points, lines, polygons, geometry, things like that. There's also a bunch of different ways you can store and retrieve the data. So it might be completely possible, although in order to give you a comprehensive answer, I would suggest have a look at the docs, because that's how I figure my way around the geospatial side of things in Cockroach. Super. DSQL is inherently multi-tenant. So there will be other users of the system. That doesn't mean it's, as in other companies using the infrastructure, that doesn't make it less secure. Although some industries, especially around finance, tend to shy away from multi-tenant solutions as a rule of thumb, although it's not a less secure product. It also uses optimistic concurrency control. AWS have been using OCC as a selling point for the database. That differs from the pessimistic control that CockroachDB employs, and we'll discuss those differences at the end. And finally, it replicates data synchronously across regions, which is different from the asynchronous replication between primary and secondary regions in previous databases. Next, we'll dive a little bit deeper, so 30,000 to 10,000 feet. So the front end will talk to a number of query processors. These perform all of the SQL operations like query parsing and planning and data fetching and aggregation. So if you run a query, you need to aggregate it. That'll all be done by the query processor. The adjudicators are akin to, at a very loose level, to the leaseholders in CockroachDB. So these these take care of a subset of your data in DSQL. Next, the journal, which we mentioned earlier, this stores post images, as AWS refers to them. Essentially, that is the result of a committed transaction as opposed to the deltas between transactions, which makes for an easier to reason about backup system because you're storing committed changes to the database. Journals are concerned with the immediate storage of changes and durability, and they are used by multiple AWS products, not just DSQL. Next, we have the crossbar. So journals are semi-ordered. Crossbars provide ordering across multiple journals, and they sit between the journals and the longer lived storage. And the storage nodes, again, they're concerned with long-term storage and periodic snapshots of data. That's how they achieve that via periodic snapshots. From a read and write perspective, the read path and write path are slightly different. The write path goes through the adjudicators, the journal, and the crossbar, whereas reads don't. They go from the query processors via a shard map with help of the metronome, which I would imagine is the atomic clocks that AWS used to achieve consistency, and that will target directly the storage, so directly reading from disk. Another question. This question can be answered later. Okay, does CockroachDB also support time series data? So time series data in a distributed database, any distributed database, is potentially going to result in hot nodes or hot ranges of data because the data is monotonically incrementing. And in a time series database, you would want to index on, at least from a secondary index perspective, but probably more likely a primary key index, the monotonically incrementing timestamp. So I'm not sure if that would be a fabulous use case for Cockroach, unless you disagree, David, but I haven't heard many of our users talking about time series data in CockroachDB.
Yeah, we do support it, but it's not an ideal use case. Usually, if it's like a small part of the application, then we're like fine with it. But if it's really like a main time series type of like, for example, like market data, it's not ideal. And just to be clear, what hot range is when we're monotonically incrementing something, then you're constantly going at the same ranges for the same information. And it creates these hot ranges, which make it hard to distribute the data nicely over the nodes in the network.
Yeah, thank you. So moving on to CockroachDB, the architecture obviously looks quite different to DSQL. DSQL uses components that already existed within AWS and some brand new ones. In CockroachDB, it's just one binary. So each of these nodes is running on a different machine, I would hope, but it's an identical binary. So the nodes talk amongst themselves to rebalance data, to self-heal, to manage the distribution and replication of data. So there's no primary or writer instance. Every node is equal. So scaling is simply a matter of adding nodes to that cluster. They use the Gossip protocol under the hood using Raft, and they will figure things out. If you add a new node to the cluster, data will be balanced across it, and it will participate in read and write queries. Conversely, if you want to scale in or scale down, you simply remove nodes from the cluster, and CockroachDB handles the rest. Talking about scaling down, one of our customers scales up by 70% or something like that. They add 70 nodes to their cluster by a baseline of around 30 nodes for every Super Bowl. And at the end of the Super Bowl, once they've collected all of the, once they've processed all of the bets that were made, they scale down by simply killing 70 of the nodes. And CockroachDB decommissions them. And because CockroachDB uses something called admission control, there's no impact on foreground traffic. You can safely intraday remove half of the cluster, provided you have enough nodes to support the workload and achieve quorum or agreement between the nodes, and you won't have any impact on traffic. If you lose a node via an outage, CockroachDB will still have, let's say we lost one node or a data center, we still have quorum, we still have a majority of nodes, so the workload continues unaffected. At very worst, we're looking at about a blip of a second or two while CockroachDB figures out what it needs to do, whether it needs to reroute queries, and whether it needs to rebalance data if the node has been down for more than 5 minutes by default. Once the outage is resolved, the nodes will update this node, the nodes that didn't go down, with any data that it missed in the meantime. And that resilience pattern looks the same whether you're at the node level, the AZU level, or the region level. It behaves the same all the way down. We've got another question here. How does data get stored in CockroachDB? In columnar format? Even if it's an RDBMS. So actually, CockroachDB, you would talk to CockroachDB in the same way that you would talk to a Postgres database. But under the covers, fundamentally, CockroachDB is a key value store. So in the SQL layer of CockroachDB, which exists in all of the nodes, there is a translation of a SQL query into something that can be a very fast key value lookup. So data is stored in a columnar format, but it is a key value store under the hood. Not that you need to concern yourself with that as a practitioner of CockroachDB. You can also create globally distributed clusters. So what we're looking at here is a 9-node cluster of CockroachDB that is actually one logical database. This is all part of the same cluster, whereas if you were to do the same in DSQL, which we'll see in a minute, it would look a little different. But this is one database. And you may think, well, if I'm writing data, how do I know which nodes to talk to? Am I going to get bad read and write latency? And the answer to both of those questions is it's actually a lot easier than you'd think, and you can offer all of your users a good experience of the application. So the first topology pattern that we employ to make things work seamlessly for your workloads is follow the workload. This is the default table topology pattern if you don't specify any others. So this works by moving what we call leaseholders, the things that control reads and writes to particular ranges of data, to where they're being requested the most. So for example, if Asia Pacific comes online first, being the furthest east in the world, the leaseholders would be moved there to give users there a good experience of the application. As time moves forward and users further towards the west of the world come online, the leaseholders will move across, and that's how follow the workload works. We move leaseholders to where they're being requested the most. Now, this might not work for all workloads. If you've got users online 24/7, this isn't a great pattern to use because the leaseholders will be constantly moving around trying to satisfy workload patterns. But we do have table topology patterns for that. Next is global data. So let's say you have reference data that is seldom changed but very frequently read. It's a good pattern to consider. You'll write data and CockroachDB will make sure that it exists as wide as possible. So your requests will take longer. If your data is, if you want to write data here, it could take a couple of 100 milliseconds to make a write. But if that data is being read from frequently and hardly ever updated, it's a good use case for a global table. And that's because everyone will get very low read latency. Now, we achieve that in CockroachDB by simply attaching the locality global statement to the end of a create table statement. It's as simple as that. Next, we'll look at regional tables. Now, you might be, let's say you're running a global e-commerce business and all of your administrative users are based in Europe. That data doesn't need to exist in the Americas or in Asia Pacific. It only needs to exist in Europe where those administrative users are situated. So you can pin that table to Europe and it doesn't have to exist in the other regions, or at least the leaseholders don't. You can actually also partition the data in a way that it never actually leaves Europe, but that's a choice you can make, and that's very easy to achieve. Now that's achieved by doing something like this. You can apply locality regional by table. If you don't provide a region, it will choose the primary region, which is again an optional configuration for your multi-region clusters, or you can provide a region. You can hard code a region in there as well. The final topology pattern I'll talk about is regional by row. So if regional tables were the partitioning of an entire table to a region, regional by row allows you to pin different data or different rows in the same table to different locations based on where that data needs to live for good read and write access to users wherever they are. Also, it can satisfy regulatory compliance as well because your US data doesn't have to leave the US, and sometimes it doesn't need to. That speaks to the use case that David mentioned earlier, whereby one of our betting customers, they need to, some of the regulations in betting, they're more stringent than in finance. And the Federal Wire Act for betting stipulates that in some areas of the country, perhaps Florida might be one, the data that is used for the bets that you're placing needs to exist on tribal land. So it needs to exist in specific buildings. So obviously, if you're running in different cloud regions, you're not going to be able to satisfy that level of granularity in data placement. We've got a question here. So from a GDPR perspective, how does the data get controlled specifically from the database admin role perspective? Can he or she see the data from other regions? The answer is yes. If you want that to be the case, we also support row level security. So if you want to lock data down completely, you can create super regions across multiple regions. So let's assume that this is a US East, US West 2, a US Central, and an a US East 1 region. You can create a super region around that. Again, it's just two lines of SQL, and data will never leave those regions. Pair that with row level security as well, and you can determine which users can access which data. By default, though, yes, if you run a select star against a table like this, you'd get all the data back. And the query would take a while because the data is physically stored in very disparate locations. There's another question here. In the case of regional or row level partitioning, does it mean that ranges would live only in those specific nodes and not on other nodes in other regions? Yes, if you want that to be the case. So by default, CockroachDB will try to replicate data as wide as possible. So let's say we haven't got any super regions or anything like that. There will be generally two copies of data within US for US data and a copy of data in another region, such that if the regions were to go down, the data is still safe. Typically, there'll be 5 replicas for a multi-region cluster. So 3 might exist here, 2 might exist here, for sake of argument, or perhaps 2 here, 2 here, and 1 here. So, but there are ways that you will still achieve regional survivability in a setup with multiple regions within a continent. Although I appreciate I'm rambling a bit, but the answer to your question is, if you want it to, yes, it can. So this also speaks to AI models as well, because what many people may not appreciate is it matters where you train your models and where the data lives. So if you're training models using EU data in the States, that's not going to be possible because you'll be breaking regulations. So it's still subject to regional regulations. And that can be achieved as follows. You'd create a table, let's call this one member, and we simply apply locality regional by row. That will create a hidden column called by default CRDB region, which you can then set to values like US East 1. If you want to call your regions like that, it's an arbitrary string, and that will ensure that data only lives where you need it to. This is what global presence looks like in DSQL. Now, because you have these region triplicates, you might have one on the West Coast, Central, and East Coast. Maybe one of those is your witness region. You're not able to create a globally distributed database with DSQL, at least not at the moment. So in that case, you would have to have different DSQL clusters. And if you wanted to gain a holistic view of your data in that DSQL database or those databases, you'd need some sort of ETL pipeline to funnel data into an additional system. So additional storage there in order to get that holistic view. So it wouldn't be real-time data. Finally, we're going to look at optimistic concurrency control, which is used by DSQL, and pessimistic concurrency control, which is used in CockroachDB. When we started building CockroachDB over 10 years ago now, we too opted for OCC, but we actually migrated from OCC to PCC after encountering many real-world use cases where production workloads were simply demanding the need, or they were necessitating the need for pessimistic concurrency control. We didn't switch to PCC because OCC was bad, It just didn't provide the behavior we wanted or our customers needed for their workloads. And this hopefully explains why. So OCC, from a conflict detection perspective, does things late. So it will allow you to go right up to the point of commit before it returns an error or an exception. So the OCC model assumes that conflicts are going to be rare, which in a database with lots of different users all needing different data might be the case. Whereas in pessimistic concurrency control, everything's done early at lock acquisition. So if you try to lock data that's already locked, this means that it's a locking system, a distributed locking system. You're going to get an error straight away. So this model assumes that conflicts are going to be inevitable as opposed to rare. As for use cases, OCC thrives in read-heavy workloads where contention is low, and the risk of and you're not likely to run long-running transactions. Transactions are going to be very quick. PCC is good for read and write heavy workloads where contention may or may not be high, and transactions can be short, they can be long. It matters less so in PCC. The behavior under contention is interesting. So with OCC, retry storms are possible. So if multiple transactions abort and they retry repeatedly, that's called a retry storm. That's possible in OCC. But in PCC, you might get queue buildup. So if you've got lots of consumers waiting to update the same row, I'm not sure why you would, but you might build up a queue of transactions all waiting to commit data. And potentially you get cascading delays from there. But not in terms of latency. So tail latency in an OCC system could be very high, and it will increase as contention increases. And that's an artifact of the repeated retries that are happening. In PCC, tail latency can be higher because of lock queuing and cascading waits, but generally speaking, PCC will offer more reliable tail latencies. In terms of fairness, in terms of transaction fairness, OCC can offer poor fairness for transactions if they're unlucky enough. So let's say you have a longer running transaction in OCC. If it's constantly trying to access data that's being updated by faster transactions or shorter running transactions, it may never finish, and that's called starvation in the world of transactions. PCC offers strong fairness in that everything's done in a first in, first out order. In terms of deadlock risk, there's no risk of deadlocks in OCC because there are no locks to wait on, whereas this is possible in PCC. So obviously, if you're beginning a transaction, you want to make sure that you commit it as soon as you're done in order to prevent deadlocks from occurring, especially if the order in which things are being locked differs. And finally, throughput. OCC offers good throughput under low contention, but it does degrade significantly under high contention, and your number of errors is going to increase. PCC offers good throughput under low contention as well, but it offers more stable throughput during high contention. So that is the OCC and PCC models compared. Neither is a better fit for any specific use case, but it's something to be aware of when you're using a database. So we're getting to the end of today's webinar. We wanted to share a quick call to action with you, which is a link to our CockroachDB Cloud, our managed service. And this will give you $400 in free credits to use to play around with CockroachDB, kick the tires, and get a feel for the managed service. So if there are any questions, David and I are available now to take them. So we'll give it a few minutes, let any additional questions to come in. It might be that there are no questions though.
Well, I think we got some great questions through the presentation. I kind of like doing it like that better. So,
absolutely. We do have one question.
We did get one. Go ahead, Rob.
So how do you connect to CockroachDB? So when you're interacting with CockroachDB, to all intents and purposes, you'd think that you're talking to a Postgres database. So the tooling that you already have for Postgres will typically work for CockroachDB. So that's your Postgres connection strings, your Postgres drivers, your Postgres facing code, all of which will probably be able to port directly over to CockroachDB with very minimal changes. One thing to note about Postgres connectivity, though, is by default, CockroachDB uses serializable isolation, which is the strongest level of isolation for consistency, whereas Postgres uses read committed isolation by default. So you can use read committed isolation in CockroachDB, but the default is serializable. That means you're likely to see under high contention more retry errors in CockroachDB that need to be retried from the client. But that's the only thing you'd need to consider. So yes, you'd need a driver to talk to it, but in the same way that you talk to a Postgres database. Next question is, how does it perform as a vector database for embeddings versus Postgres? I'm not able to give you a definitive as to how it performs against Postgres, but being a horizontally scalable database where the vectors are geographically distributed, you're gonna be able to run much larger vector workloads against CockroachDB than you would be able to in Postgres. Obviously, if you're manually sharding your vectors in Postgres, you'll be able to achieve higher throughput there, but it's a question of whether you want to manage manual sharding in Postgres or not. We have invented a custom vector indexing algorithm we call CSPAN, which uses a bunch of great contributions from Google, Microsoft, and the like, along with a quantization model called RabbitQ, which ensures that vectors are kept small from a storage perspective, but they can also be indexed immediately when they're needed. So it works in the same way that any other columns exist in CockroachDB, and you can run Euclidean distance, cosine distance, and negative inner product distance searches. So having, at least as a practitioner myself, I found a benefit in being able to run vector queries from within my relational database and my relational queries. And then there's another question. How does migrating leaseholders and global load balancers work in terms of connections and in connection pools and IP caching? IP caching, I'm not 100% sure, but if you're running, so load balancing isn't a concern of CockroachDB itself. You would want to use your own either software or hardware load balancer. So think HA proxy, F5, things like that. Or even in the cloud, you can use those kind of application level, network level load balancers. In our managed service, we have a global load balancer endpoint, which is geographically aware. So it will route your queries to the nearest region. And under there's a load balancer which will route your query to a node within the cluster. So in terms of load balancing and leaseholders moving around, it's not something you need to worry about because CockroachDB does all the leaseholder management and sharding for you. So I think that's all the time we have for questions. We will be sharing the slides after this, and we'll also be sharing a survey. So if you want to see any specific topics, if you've got any feedback from this one, please let us know and we can make sure that any future webinars are better. David, thank you very much for joining me, and thank you for your
as
input.
always. Awesome. Thanks, Rob.
And thank you all very much for joining us today.